Hello viewers, in the last video we talked about the closed flow filtration, okay, where the feed stream flow tangentially over the surface of the membrane. So you can see here we have the membrane coupled inside the assembly, okay, where the flow is tangentially over the surface of the membrane, okay, and some of the feed will permeate through the membrane while the rest will continue to flow through the system as a concentrate. So this is my concentrate here and this is my permeate, okay, which we are going to calculate in terms of, for example, we are doing salt detection, so we are going to find out the TDS, okay, or the salinity, okay, and the tangential flow across the membrane reduces the fouling rate by increasing the back transport of fouling agents from the membrane surface through internal lift or surface drag and shear diffusion mechanisms. The feed tangential cross flow also reduces the concentration polarization formed at the membrane surface, further reducing membrane's fouling rate. So in the last one we saw that first of all we were putting the membrane here. So already the membrane is coupled here or put here inside the assembly. Okay, so first of all we have to wait for a couple of minutes so that the flow becomes normal or for compaction, okay, and you can see here two assemblies here, so you can operate them simultaneously. For now we are operating only one part, okay, and for switching on we have to switch on this module, okay, and wait for the these to appear. And here you can see there are two digital signals you can see. So here we are operating at in psi, so 14 psi is equal to 1 bar. So now we are operating at 2 bar, which is equal to 28 psi, okay. And from here we are not operating this module, so we are controlling the flow through here. So if you see here I'm rotating this way, so the flow this pressure is increasing, so I will keep it up till 28. And for switching off, what we have to do, this is emergency shutdown, shut off, okay. So for closing, we have to open both the valves and open this valve also. So now it is in operating mode, okay. Now at this pressure, which is around 2 bar, so I have collected here 10 ml of the sample in around 1 minute. So I'm going to analyze, and this is my water, okay, with tetracycline, or you can say tetracycline dissolved in deionized water. Now we have already watched in our last consecutive videos about the tetracycline calibration, so we will press start and then put our cuvette. For first of all we need to zero, and this is around 21 ppm. We are again increasing the pressure here, so we'll make up to 42. It's around 42. After setting the pressure, we will again calculate the flux, okay, and also find out the separation for the tetracycline using the added the membrane in this module, or you can say in this assembly. So we have added the membrane, which is biochar based membrane. This is my biochar based membrane. So we have cut the membrane according to this shape, and then we have added to the module. Now usually when we set the pressure, so we should wait for 1 hour so that the system stabilizes, okay, and also the water which is passing through the membrane, okay. Now what we will do, we will take the sample again So usually it takes 1 minute to fill 10 ml. Okay, and since here the pressure is very high, so it will take less than a minute. Now we will measure this. So you can see significantly dropped from the first batch, or you can say first set point pressure. So earlier it was around 21, so now this is 13.8. So we saw on 2 pressure the flux also, the time required for collecting the flux also dropped, and also the separation now is much better than the first one. Now guys, for closing, what we have to do is, first of all, we would open this valve in this way, and also this has to be open. Okay, now what we will do, okay, and then we would close this pump. Okay. Now the pump is closed. Okay, and then from here we can close the machine. Okay, and here there is a bypass valve we need to open and purge. And you can see slowly and slowly the water is going out from here. Okay, now we can open this module. You can see there is no water here when we open the bypass valve, so there is no water. And at the back you can see that this is the temperature control, permeate, return, which is optional. There is relief return, bypass, and these are concentrate return. These I have opened the module. Now I will show you how the internal setup or configuration looks like. This is my internal setup where the membrane is sitting. If you see, this is my membrane. Okay, and below this is a mesh. So this is my membrane. Okay, and this is my upper portion, which is mounted on the top of the membrane. So this was all about the cross flow RO reverse osmosis system. Okay, and the brand name is Sterlitech.